good afternoon, good morning, everybody. Welcome to another episode of Cloudicorns, a podcast about cloud, about technology, and everything that matters. I'm super happy to be back today. It's been a very long time. We recognize we've had some very busy schedules, Diego and I. So I'm happy that you could join us, Diego. And today we have a very special guest, a fellow Googler, Vlad Kolesnikov. So before we go into intros with Vlad, Diego, how are you?
Doing great. Now relocated in a different country, in a different part of the planet. So the pretty pretty good to have our first podcast from Austin, Texas. So thank you, and happy to see everyone back into the podcast, and happy to have Vlad tonight with us.
Absolutely, yes.
Hey,
So
thank you
Vlad,
for having
welcome.
me.
Of course, thank you for joining us. It's great to have you here. Vlad and I have been working together for a while. Well, since I left the Cortex team, we're no longer working directly, but he's a pleasure to work with, and I think we're going to have a great episode today. Vlad, why don't you tell us a little bit about yourself?
Well, I'm a machine learning engineer on the Cortex team currently at Google. I've been at Google for uh, 2 years, just a bit over that. Always was in this position, doing different machine learning, working with different machine learning use cases with Cortex. Prior to that, I switched a lot of roles and different companies, but the majority of my professional time, 15 years, I spent at Microsoft. Again, on different positions, starting from consulting, going through evangelism or DevRel, which this name may be more familiar for other people. Then I went through program management, software engineering, solution engineering, and then I moved to Google, basically doing solution engineering. That's sort of my background in terms of the technologies, because I'm this is a technology podcast, right? That again went through a lot of perturbations. Like prior to Microsoft, I was C++ developer on Windows, doing some low-level stuff, those system tools and things like that. Then I went in consulting. I went to SharePoint as a technology. I was helping our customers to deploy corporate portals when SharePoint was on premise. No SharePoint Online thing or no Office 365 back then. And then the evangelism was all about Windows Phone, fun times back then. And then it was a lot about mixed reality. You probably remember HoloLens was a big
Yes.
thing back
Oh,
then at
yeah.
Microsoft. Virtual reality. Then I worked on Media Foundation, specifically in application of for 360 videos and how you stream DRM'd videos. So a lot of those, again, low-level details. And then when I started working on solution engineering, this is where I switched to ML. Not, and we're gonna talk about that in details. Not the
Yes.
ML not AI that everyone is used to these days. It was more traditional ML. Yeah, and now I end up doing a lot of generative AI applications, which is part of machine learning. And I guess we're gonna talk a bit about this today.
Yes, exactly. That's the thank you for the intro, Vlad, and also our viewers are going to be delighted, to get to know you more. But what is AI and GenAI, right? So so this is one of the topics that has been around recently very very profoundly in the ecosystem, right? Technology ecosystem. But how will you describe in your own words from a person who is hands-on and not marketing hyper? What is AI and how they contrast with GenAI from your perspective?
You know, AI in general, and it AI in general is sort of like a bigger thing, sort of like a big umbrella term, both in terms of marketing and in terms of technicalities, right? Then there's this machine learning thing, and what people mean today saying AI, it normally means machine learning, meaning that we use machines, we use computers uh, to learn something, and we we can talk about it in details, and most of you sort of understand what that means, like what it means that machine learns something. And then ultimately we give it a new input, and then it gives us some output, right? And there is a lot of analogies in how machines think and how AI is implemented, and with what people do when they're thinking. And surprisingly, it's actually partially true. There's a lot of implementations in machine learning and the transformers technology that generative AI is based on. We can talk about it separately. Has a lot of things that's sort of like taking from not computational biology, but more like neuroscience.
Yeah.
Just looking at how people do this, etc., etc. So yes, it's sort of like trying to make machines think. From the technology perspective, the machine learning. Let's talk about machine learning. It's just, for me, easier to call it this way. It's when you build a system that implements a function. If you're like good with math and calculus, like imagine a function with a lot of parameters. It's a huge function with, like, I don't know, billions, sometimes trillions parameters. And the funny thing that, you're trying to solve the equation, basically, or a lot of equations. You have your input and you expect a certain output, and this is the information that you use to learn, right? To teach the model. You as a human, you use this information to teach the model. Like, okay, I have this input in some form, whether it's text or it's image or it's audio or data, whatever, right? And I want this output. You give it to the machine and you say, oh, you have this huge equation. Please process this as your input for this equation and give me output. And it gives you something else. And then what do you do? The funny thing that in machine learning, what you do is like, you pretty much randomly adjust those parameters of your equation and try again. And it gives you something else, maybe closer to what you want. And you're like, okay, let's adjust it again. And then you have a lot of these examples. And because modern machines have this, CPUs and GPUs that are really good in doing things in parallel, you can do it fast. Right? That's pretty much what machine learning is. Then, of course, over the time, people learn, I was like, maybe we should not adjust those parameters entirely randomly. Maybe we should use like more sophisticated function, and the operation is called backpropagation, when you essentially try to kind of see what the difference between results and how you calculate the difference. That's the whole other conversation. But ultimately, you use sophisticated techniques to like, oh, let's adjust those parameters and then see what happens. That's essentially how it works. In terms of like how it works with people, we can quickly sort of like touch that. The way people or mammals in general learn with the neocortex is that you have your input as the input of your senses, right? You have a lot of senses, like your visual, your like how you touch, what you hear, etc. And then you have information about how you move those sensors. That's also part of the input, like the actual signal and the movement. And then you give it to these little networks that run in your brain. And what networks predict is like what's going to be the next input. They effectively predict what I'm going to feel next. And there's a difference always. You expect things, your expectation don't match reality, right? That's the usual for people. When that happens, you want to adjust your expectations or adjust the reality. So you want to do something, right? So you produce adjustment in a bunch of neural networks that are inside your brain. And that's actually good to know. There's a lot of them. It's not like one big network. So you can predict next thing better. And sometimes people adjust the way they expect things to happen. Sometimes they're like, no, I'm going to go and change the world because I believe that's how it should be. It's on the grand scheme of things, but the funny part that it's actually work. It actually how it works at the very low level even.
Yeah.
So that's essentially how it works and how it's similar to the way like
Your brains.
animals learn. It's a bit different for snakes and all those kind of not so advanced creatures, but again, let's not talk about it too much. Then for generative AI, since you mentioned like how generative AI is different, so generative AI it's just a family of machine learning applications, and in many ways, when people say generative AI, they mean certain kind of neural network architectures, the artificial neural network architectures. When you use architecture that's called transformers, that was introduced by people from Google a while ago. I'm not sure how many of them still stay at Google. I think at least some of them are still there and advance the technology inside the company. Others, they advance it in the industry. So either way is great.
But it was through a white paper, right? So they released a paper, an academic paper about it.
Yes, and the white paper was the result of their research.
Exactly, yeah.
Again, there's a lot that they talk about. They talk about attention, which is also a big part of mammals' thinking in neocortex. Again, another analogy with the mammals or people. Then they were talking about the word prediction essentially, and this is where sort of like 5-year-old, like an explanation for 5-year-old, like what is generative AI, what do all those networks do, and you essentially say they predict words. Like you tell them as like a sequence, a sentence of words that you have, and they predict the next word. So it's sort of like glorified autocomplete. Very smart and very expensive.
We should make a T-shirt. GenAI, glorify autocomplete.
Yes. So that's what they do, but surprisingly, this is what people do as well. Like when they start researching how brain, as far as I know, but from what I read, when you start building the sentence, this sort of like word prediction, this is how we work. Word prediction. There's more about this. They actually don't operate with words. They operate with so-called tokens, which is normally a part of the word, but in grand scheme of things, it doesn't matter. It's essentially you predict the next word. Now think about like these networks, they're huge normally. They read a lot of books. If you read a book, they probably read it too. Right? So they have a lot of knowledge around different sort of like our society and businesses and science and everything. This is why when you start giving them something that they've never seen before, they have enough sort of like statistical knowledge. They have enough just like pieces of those words to understand what would you expect to see next. And because they've got a lot of information, we could see how sometimes we see very niche scientists, like basically like there are 2 or 3 people doing this kind of research in the world, and only them can understand each other, but they publish their research. And then because the neural networks also read the same things, like their research ended up being in the training set of big LLMs, and LLMs are the large language model. That's the models that we're talking about. Those LLMs ended up understanding them and actually describing their papers, etc., which was for them, and I read those threads on Twitter, which for them was like, oh my God, there's something else we can talk to finally.
I'm not alone. I'm not alone.
Exactly. So that's how the scale actually solves. It's the same with the scale of compute and the scale of internet, and how essentially technology, like the internet, became the economics of scale. As soon as you can run things in parallel fast across many little machines, that's how Google started, right? Or little pieces of compute, right? That doesn't necessarily a physical machine. You're gonna achieve great things. So LLM, it's also economy of scale. Like not LLM, the generative AI is in another economy of scale, where you can generate information and process information at a high scale, and you achieve an illusion that they actually understand something. Just because like they're really good in giving you, largely giving you what you expect. This is also why, and that's the second thing, they can hallucinate. But so far, because we talk about hallucinations, do you have any questions?
Yeah, yeah. I think Lucia, you have a question, right?
Yes. So you mentioned you're talking about scale,
Mhm.
and I think that's related as well to why now, right? Because as you said, transformers have been there for a while. The concept of AI, you used to joke, I mean, amongst us friends and not as a view of our employer, that AI is in slides and ML is in Python. So that has been there for a while. It also reminds me of the hype of machine learning. What was it, 7, 8 years
Mhm.
ago? In which, if you didn't have machine learning, your company was doomed. And if you wanted to make big bucks, you needed to know machine learning or be related to machine learning in some way. It feels that there's a lot of the same type of hype with AI. And because you're mentioning scale, I wanted to ask you what your take is on this. What is hype? What is real? Because there's a lot of merit to the actual technology as you're describing. And where do you think this is trending?
That's a great question. Before I answer it, I'm actually going to refer to the phrase that you shared. If it's in slides, it's AI. If it's in Python, it's machine learning. It was said by Matt Veloso, a longtime friend of mine, who's now a vice president at Google, and we used to work at Microsoft together. It's his thing, his joke. So in regards to the hype and those waves of hypes, um, those waves normally comes with some advancements. Like there's a huge jump, huge advancements, and suddenly we all golden. It's popular, and then the hype goes down naturally, not because something fails. It's naturally hype goes down, and then we wait for another breakthrough. So there are multiple breakthroughs, and the one that I remember, which was in kind of between 2000, I don't know, 2010, 2015, sort of back then. And there were other times when ML was sort of like a popular thing. But back then, uh, a few researchers, and I forgot their names, I'm really bad with names and stuff, released ImageNet. And ImageNet was a combination of neural network architecture, but the most important part of that was a training set. They had a lot of images that were labeled, and they shared it for everyone. It's like anyone can use that. So because they had this materials now, and a lot of researchers got them, and like for free, you can use it now, and you can train your models, whatever model architecture you have. There was a huge investments in different architectures, in different things, because oh my god, now I can actually train my models at high scale. And at the same time, they've got enough advancements in hardware. The hardware advancements ultimately gave this opportunity to do what they wanted. Because previously, again, it was very slow. I remember myself having like a Titan Z GPU from NVIDIA and being super proud. And it was like absolutely ridiculous price. And I had to change the power brick on my PC because it was too weak for Titan Z, and I was able to run networks. I wasn't talking about training even, because for training you need more than this. So that's essentially how it comes. Like you get something like a new research, a new set of training data, new hardware, and then boom. And then obviously you need good marketing. That's another thing. The current advancements, it has enormous amount of hype. Obviously, it's in many ways based on FOMO, on fear of missing out. But there is one difference, and it's actually very similar to what we had with the vision advancements in like mid 2010s. There's a lot of real things behind it. It actually can help your business, and it can do something that we were not able to do before. And with the generative AI, obviously, the majority of this jump came from the fact that they were finally able to create or build clusters of GPU, because even with all the GPUs that we have today, we're not able, now the networks are so huge that we're not able to fit networks and one GPU. So they figured out how to split them and how to train neural networks across different GPUs. And there is a lot of overhead when you do this, the computational networking, whatever overhead. But because the GPUs are so powerful these days, and we can build them together like in such huge quantities, we can overcome that overhead and say like, it's sort of acceptable, it's fine. And it's not as expensive because again, like we can optimize things, and everything in hardware goes kind of down in price, so we can do it. That's the usual thing about computers since, I don't know, 1970s. The Moore law and everything. They just like build things, and they're faster, cheaper, etc., etc. That's what moves the progress in our industry.
You mentioned something there as well. Before we go back to hallucinations, because I think it's also related to my next question, which is, you mentioned there's real applications in enterprises, which I have seen myself. And you and I, we actually worked on some of those. So could you tell us a little bit more about that and the dangers of these things hallucinating while they're at it?
Yeah. So in terms of applications, let me actually a bit roll back and think about like the previous hype time, which was around the vision. And I was part of that as well. I was very interested and started looking early on when those papers and libraries started to appear. Again, people thought, oh, now we're going to have neural networks that can look at things, and then they're going to tell us what they see and where it's located, every pixel on the screen. They're going to understand the shape of those things. They're going to communicate as like 3D shape of what they see. And we're going to be golden. So many great applications. We will be able to understand the world just by looking at the video footage, etc., etc. At the time, it was extremely inflated opinion that it was just too heavy. Networks were not as good. Training sets were not as good. But then a few years later, sort of the hype went down. That what I started seeing and working myself on is different applications. When people start detecting objects, they detect animals to understand how animals move, in different sanctuaries, like in Africa. They start detecting people in dangerous areas, like at plants where like you're not supposed to cross a road somewhere, like they see it and they sort of like send an alert, or you're not wearing a hard hat where you're supposed to wear a hard hat. So a lot of applications around safety. Then these days you show up at the airport, they look at your face, they say, oh, hi, Vlad, please welcome, etc., etc. So kind of nobody at this point complains about the capabilities. People can complain about, in general, safety of those applications and privacy, which is important. And now we see, in my opinion, personal opinion, sort of the same path that we go with generative AI. Because yes, there's a lot of expectations. We think that now, like some people say, people are going to be replaced. Oh my God, it's AGI. artificial general intelligence. We were going to be out of jobs because neural networks are going to do everything for us. I don't think it's going to be the case, but they definitely can help us. And yes, the hallucinations, Lucia, the one that you mentioned, is very much part of it. But ultimately, if we look at what we realistically can do, it's that we can do a lot of things with different applications in terms of generating the content and even understanding the content, sort of like explaining it to us. But we have to be very well aware of current limits. And the progress doesn't stop. Like, we will eventually have very advanced AI, but it's going to take time. Like today with object understanding and 3D reconstruction, I can now do it on my iPhone. I don't even need like cloud or big GPUs or anything. These things now run locally on my device. And 10 years ago, it was like, oh my God, yeah, everyone is talking about it, but this is not something that we can do. Now, 2024, fast forward, we actually can do this. We can recognize objects, a huge variety of different objects. We can do 3D reconstruction of the reality because compute and ML optimization, they just made it through for 10 years. It took 10 years, which is honestly a long time in this industry. Yeah. So with LLMs today, my ultimate sort of like, I don't know how the rule of thumb that I use is that every result that is produced by generative AI better be verified by a human.
Yeah.
It doesn't guarantee anything. Humans actually make mistake. I've seen very serious applications running and people being happy with them while they are producing wrong results. But they're like right enough, close to the reality enough for people to be happy. Same with with generative AI. When you build an app and you run it, it produces wrong results. Or no, let's actually start with the situation when it produced the right results. You verify it, you run it again, you verify it. It seems to be right a lot of times, like 99% of the times. And then you just start trusting it. Same with people. You hire a person. At first, you're like, even if the person like is super experienced, you tend to look at them as like, are they really that good? And they do things right, and then do things right again and again and again. It's like, okay, like they can do it now, no problem. But then mistakes can be made. So you cannot rely on artificial intelligence in general and say, yeah, they're gonna do everything right. They know better than us.
They're not accountable for what they do.
Yeah,
right?
they are not accountable, and it doesn't really matter if they're accountable or not. They just make mistake because all they do is they predict your words. Even if you think about probably the most production ready kind of apps, which is in my opinion image generation. Remember Photoshop and how you can edit things and they just like appear. Mm-hmm. They still can generate, like I've seen examples of so hilarious things going there in Photoshop. So you're gonna check it. And the good thing about the Photoshop thing and image generation in general is that it's always for people to see and decide whether it's good or not.
Exactly.
It's just a natural process in that industry that you produce a lot of different designs,
variations
pictures.
Of it. Yeah. Mm-hmm.
Yeah, exactly. And then you decide which one is good. When you think about running, like using language model to run a business, like to make business decisions, let's put it this way, or to help you make business decisions, that's a different thing. Like if the model, you ask a question, the model behind the scenes runs some operations, maybe SQL queries, maybe calls to different systems, and then it comes with an answer. The issue with this is that you cannot actually judge properly whether the answer is good or not. Right? So you need to come up with a lot of explanation how this answer was made. Part of those explanations normally are understanding them require different skills. Again, I take something that I'm familiar with. You take running SQL. You need a data engineer to understand what that SQL means. You talking about how you extract data from external systems. LLM can actually tell you, like, I did this and that. You need to know these external systems to understand whether what they've done is actually right. And then thinking about the general algorithm of how you're making business decisions, it's the same thing. You better read it and better be a business analyst and actually understand where you're at in your company, in your business, in your business process to decide whether it's right or not. So ultimately, what I can say in terms of just operating it today and not sticking to the hype entirely is artificial intelligence doesn't eliminate people's jobs. It makes us more powerful. It gives us a bike. Like we used to walk, now we have a bike. It's still not as fast. The bike can break. The bike can miss pedals or even wheels sometimes. But normally it will help us go faster. But ultimately it's on us to move from point A to point B.
To drive it, yeah.
Yeah. So that's the analogy. Hallucinations, since we mentioned that multiple times, and I was the first one to mention today.
You brought it up.
Hallucination is effectively when the model produces something that you don't expect. So, or you know it's wrong. So the funny thing that ultimately everything that they do is a hallucination. It just sometimes it seems to
It's
be
the right one.
yeah, it's the right one. It's according to your expectations, right?
Yeah.
And when you don't know what the expectation is, well, or it should be, it is a hallucination. There's a lot of balances and checks the industry currently puts in place, so you can sort of like guess whether the model hallucinated or not. And there are different techniques. The most popular of them is grounding, when you can have a set of information and you can check the results whether it's grounded in the reality, and you try to explain your business context within that grounding, or like use case context, situational context, depending on what we're talking about, like what kind of questions you're asking, what you put into the model. But ultimately, this is what happens, and the model is a predictor of words or predictor of pixels on the image. So everything it does, it just tries to predict. Sometimes it's wrong, and the worst thing is that when we have these conversations, when we have a growing context of information exchange between you and the model, when somewhere at the beginning it hallucinated and you were not able to catch it, it becomes part of the reality for the model. So it starts hallucinating further, because now, like, oh, that seems to be
it's on top of
part of the conversation. Yeah. But look, it's the same with the people. Like, we discuss a problem, we make a wrong assumption or somehow get the wrong outcome of a sub problem, then we take it as truth. And we suddenly deviate somewhere that is completely nuts. And sometimes it's like it made it too late to understand that we made mistake at the beginning. It reminds me on assembling IKEA furniture. Like, you make one mistake at the beginning, at the very end you realize it was wrong. You have to disassemble everything.
You finish it, you have 2 screws on your hands. It's like, oh no, what did I do?
Exactly.
Yeah.
So it's no different. It's just people have a lot of intuition, a lot of information. So we are ultimately good at generalization. This is why we can spot problems early. And I believe, just like with vision, we will eventually get to better models, making better decisions, and really automating our day-to-day life in a big way. But we're just not there. Yeah. So, and everyone is an early adopter, and the industry changes really fast. I will not be surprised if something that I've said today will be wrong tomorrow, which will be unlikely tomorrow, maybe on Monday, because today is Friday. This is when we're recording it.
Disclaimer, Vlad. This is an excellent disclaimer you're making right now.
No, and the thing is, the point that I'm trying to make is there is a benefit of hype.
Yes.
There's so much resources currently.
Investment.
Yeah,
100%.
Like both from the investment perspective and the number of people who are investing their time and whose job is generative AI today, that the field advances at absolutely unprecedented pace. It's crazy. If you want to be like an influencer and talk about like everything that you can do, it's just to read summaries. You can ask actually large language models to make summaries of all the news and papers for you, but because it's absolutely impossible today to read everything and know everything about what's going on in generative AI at big scale, actually, right? Because it's not like the main things and then there's a lot of noise. There's a lot of main things going on, both in the open source world and closed source world. And I can only imagine what big hyperscalers have in their hands to release and disclose, because it's going really fast.
So
That's sort of
in that line of thought, what from your experience and all these years you have in the machine learning space, what would you recommend, like someone one of our viewers are watching today, what would you recommend for them to get started with this, right? So what are your kind of cornerstones to get started in a proper way, right?
I would say start with, if you're not a software engineer, and even if you are, if you've never tried with this before, which probably means you're living on the moon, but fine. If you never tried this before, go to, I think the address is gemini.google.com, or you can Google it and play with Gemini. Imagine it's you work for a company and it's your intern. Don't expect a lot from that thing. Right? Ask questions, see what it does, give it more sophisticated questions, throw some data, right? If you want to go a bit more advanced, try AI Studio. It's actually like a sandbox where you can experiment with more advanced things and different models, not only like the Gemini model that's currently exposed in the website. Try that. I think there's more advanced Gemini model, which is Gemini 1.5 Pro, which has a 1 million context window. We didn't talk about context window, but
no,
we can.
We're leaving out temperature like this type of stuff.
We can go really deep, but that model is really advanced because you can throw in it like through like the whole videos and books and even language books, and it can learn languages just from your question. If part of your question is the book that teaches it language,
write this in Klingon, and you just give the Klingon.
Yeah, as soon as you have Klingon, like a book about Klingon, and you can learn it. That it's just how much information this model can take at once.
Yes.
That's about it. So this is sort of like pre-programming, and then if you want to go further, like first recommendation, I'm gonna tell you into like if you wanna start coding against generative AI, like everything in ML, it's very opinionated view, but learn Python. Okay. Yeah, you can say, oh, I can do this with JavaScript or C++. Yeah, a lot of people do it, including like speaking about C++. Yeah. It's very popular even for AI applications.
But I
learn Python.
Yeah, I think a brief justification about Python and being opinionated about that, like all the good libraries are in Python. Why would you go somewhere else, right? So
exactly, all like samples and tutorials. It's just the way it is. And Python is a great language. I used to hate it. I was a developer when I first tried Python.
What is this?
I hated my job at the
Java
point.
or .NET or C?
No, it was C++, then .NET, then Python.
Yeah.
Before that, even before C++, it was Pascal. Anyways, learn Python, and if you already know some Python, try LangChain library and tutorials that you see. They actually give you a lot of understanding, like look at basic tutorials at the LangChain website. Again, Google LangChain, you don't have to know any addresses. Maybe we can give people addresses.
We can put,
And
we can
like
put it,
We
when
can
we
put them in
post this
the
yeah.
podcast,
description. Yeah.
yeah, go there, read basic tutorials, try basic, basic machine learning models. Yeah, there is some learning curve in terms of like configuring those models, whether they're by Google or not. Maybe you will need to pay some money, maybe not. I'm not sure about that, by the way. Or like you at least need to like configure billing accounts and all that boring stuff, because ultimately, they all want money. This is how we fund the generative AI and can advance it further.
Yeah.
But anyways, getting started, it's dirt cheap, if not free. I'm not sure about free, but
It's close to it.
yeah, it's close to free. And just start trying. Start looking at the data that you have, or if you want to do it with images, look at images. Although I'm going to say LangChain is primarily focused on text-based applications. They have some exceptions.
Yeah.
And then when you go more advanced, then you can jump on Hugging Face, which is another company and another set of libraries. Hugging Face is more flexible. Hugging Face existed
Since before of all these.
before this hype, but yes, they created Transformers library for Python, and essentially before this whole hype like blew up, they were already doing this, and they were doing great applications. And my very first generative AI applications that I built when I was already at Google, and it happened before the hype, and it was using transformers with custom models, not those models that are currently hosted in huge data centers, because they are the only ones who can possibly run it. Those were models that were small, and they were still doing great job for what I wanted them to do.
That's awesome.
That's the recommendation that I have. And that's actually how I've done it myself. It's pretty much the same way, except I tried transformers first before LangChain, because LangChain didn't exist back then.
That's awesome. Thank you, Vlad.
Thanks so much. I know, Diego, that you have some practical experience around this too.
Yeah.
But we're going a little bit over time.
Over
So
time, for
maybe I can put you on the spot and say that the next episode we can do, we could break Vlad in if his game and talk about the applications that you've been working on.
Absolutely, yeah, that would be awesome. We can do a little bit of bots versus LangChain versus Asians versus Cruise, and just play a little bit around it. So for sure.
Yeah, we can talk about contexts and their sizes. Deep
Context,
dive.
temperatures, multimodal. There's a lot of stuff to discuss for sure.
Yeah.
Perfect. Okay, we have a plan then. And thank you both for joining today. I think this was a great talk. It is great to be back finally.
Finally,
And I hope that folks enjoyed it, our listeners, our viewers. And if you have any feedback, any questions, and suggestions, we're always open to listening and reading. We like that a few folks reached out and asked why we had disappeared, and it had to do with our personal lives being a little bit hectic. So please keep the feedback and the comments coming. And once again, thanks a lot, Vlad. Thanks a lot, Diego, and have an awesome rest of the day.
Thank you so much for having me.
thank you.
Bye.
Take care, guys. Bye.